Welcome to Field Intelligence by Fluix. Conversations with industry leaders about reshaping field management safety, productivity, and performance.
Hi, everyone, and welcome to Field Intelligence. For anyone listening for the first time, Field Intelligence is the podcast where we sit down with the people who run safety, inspections, and field operations for a living. And our goal here is simple: we give the floor to people who know this world from the inside and learn from them. As we at Fluix build inspection software for field teams, for us is the great opportunity to see the people who we build it for. My name is Dimitri Adamian. I work closely with all our renewable energy customers at Fluix, and my guest today is Cristina Fernandez Alonso, Blade Project Manager at GE Vernova. Cristina, welcome, and thank you for joining us today. And I think the most obvious way for us to start is for me asking you to tell a little bit about yourself, about your role, and what you do in this day in your career.
Hi, Dimitri. Thank you so much for having me. It's a pleasure to be here. My name is Cristina Fernandez Alonso, and I'm a product service engineer in offshore wind. My role is focused on improving turbine reliability and supporting our fleet throughout the full life cycle of the assets when we are especially facing technical challenges. My career path has been a natural evolution over the energy sector. So I have a materials engineering background, but I started my career in oil and gas for 2 years. Then I moved to gas turbines in GE. I joined the company 11 years ago, and I have been since 2018 working in offshore wind industry based in Germany, in Hamburg. So when I started as an Edison engineer in power, then I get a lot of insights about what are the challenges of the industry. And as a field performance engineer in offshore wind, I have been analyzing the data. I have it also maximizing the asset availability, and this gave me a massive overview and very valuable about what this business that later helped me out into the role of blade project manager, where I focus more into blade life cycle and structural integrity of the blades. Combining this technical background and also teaching during my part-time in Offshore Wind Academy allows me to close the loop because I'm training later on the people who will be executing this scope of work on the field.
Thank you very much. Speaking of you teaching at the Offshore Wind Academy, right? So as digitalization changes how technicians work in day to day, right? And probably it's much more different from how it was 10 years ago or 15 years ago. How is that changing what you teach technicians and engineers there?
So training has been always a key and essential part of the wind industry because technology is evolving very rapidly. The turbines we are operating nowadays are much larger and also more complex than the ones that we had 5 or 10 years ago. When I teach technicians, engineers, or even business developers as well, I always try to combine this theoretical knowledge with the reality that we are living on the field. What does it mean? This means that we need to implement digital tools that are also changing the way we work. So technicians right now, they have access granted to more information, to digital tool inspections, mobile applications, and better documentation workflows. Back on the days when I started my career in 2018 in offshore wind, I was doing inspections in Belgium in a small prototype in Belgium, and we were bringing printed leaflets with all the information. Nowadays, no one is carrying this kind of data. We have an iPad, and everything is linear with digital tools, but technology doesn't replace expertise. This actually increases the importance of having people who understand the data behind what does it mean in order to make the right decisions. The future technicians is not only someone who just perform a task, but is also someone who needs to understand the bigger pictures. So digitalization allows us to shift from training based on how to repair to training based on how to diagnose and prevent throughout this trend analysis.
So, do I understand correctly? As we can sum it up, technology does not replace people, but it makes those experts in the industry actually better experts and do their job better, being able to, let's say, do something that they weren't able to do before. So, this is an enabler and not something that replaces them.
Correct.
If we let's say, double down on this, on the digitization. So, where have you personally seen digitization change how inspection data moves from technician to the actual decisions that management makes?
Technicians, I mean, there's here a huge collaboration among different stakeholders. So the technicians are the ones collecting the data and executing the job offshore, but there are many other stakeholders involved into this process. We have also the FPM team. This is fleet performance management. Those are the engineers that are entirely front line, so the ones receiving all those challenges that we are having offshore, and they are collecting this data provided by the technicians and then doing their own investigation, meaning the root cause analysis to figure out the origin of the issue. Then we have also the design engineers. Those are the back office engineers that are capable to implement any kind of retrofit upgrades in the turbine technology, design changes. We have also the planners that are organizing all the interventions that are happening on the field. And then we have management, a top management team making the right decisions based on all this information. So in the past, information could be fragmented in between different systems, reports, or people. Digitalization is helping us to create more visibility and also more traceability. A finding that is identified by a technician offshore can be captured, analyzed, and connected nowadays much faster to the engineering people who are the decision making process. And the biggest benefit of all this digitalization process is not only speed, but also a matter of better communication. Because when everyone is looking at the same information, collaboration is much easier. Just to bring an example here to illustrate the situation, when we are doing with a blade finding offshore, capture offshore, having the good quality pictures coming from the drone campaign, measurements, or deeper investigations can completely change how quickly you can decide for the next action. Meaning, like, shall we stop the turbine? Can we take the risk of operate for 6 months? What are the timelines that we need to play here in order to bring the right remedy plan at the right timing?
My second half of the question was whether, can you confirm whether digitalization improved team collaboration and the whole visibility? And seems like I don't need to ask that anymore because that gives a great example of how it actually works. Um, and if we talk about the safety side of all that, right? So when we're talking about wind industry, whether it's blade inspection or anything else, so safety and compliance are at the core of all the operations everywhere. Can you probably please walk me through what a blade inspection actually looks like offshore? Who's doing who's doing it? Who does what? What's being checked? How it is being checked? So maybe for somebody who never seen that side of business, how that actually looks like on day-to-day basis.
Yes, thank you for this question, Dimitri. First of all, as you well mentioned, safety first. This is the first norm in our environment. We are talking about a very demanding, very challenging environment. So we take safety very seriously. And then a blade, we need to acknowledge that is operating under very demanding conditions while working offshore. It's not the same one blade installed in onshore fleet rather than offshore. Here we are exposed to millions of low cycles, strong winds, rain, salt water, and very much temperature variations and oscillations. So, a typical blade inspection offshore involves several steps. So, first of all, we are planning our drone campaigns that are happening usually annually. In other wind farms with more defects or more problems, maybe we can reduce the periodicity, so every 6 months. And we need to plan this accordingly. We need to choose, first of all, the right weather window in order to have the access method, because we don't want to take pictures with a drone operating autonomously and to get thousands of pictures that are with poor quality or blurry. So we need to select the right weather window. We need to get all the drone campaign permits, because every country has different work permitting to fly drones, and we need to provide the right risk assessment. Once all those paperworks have been accomplished, we can start the drone campaign. And behind this mapping of all the blade effects taking pictures by a drone, there is also AI. So they are categorizing all those thousands of pictures in order to get a better assessment. So then there is a quality team behind those drone campaigns, those pictures. So they are doing a first evaluation. But this is not enough. We have also our design engineering team doing a third revision of this data. And sometimes could happen that the engineering department, they need more valuable hints, insights. Therefore, we are sending sometimes for some doubts, some rope access technicians in order to conduct exploratory investigation or to take some measurements. For example, when there is an unknown lining strike bypass that could overcome the lining protection system and has burned the laminate of the blade, we have maybe that need of sending a technician on ropes or even on a platform access while the defect is massive, is larger, and we have to accomplish a larger repair. So those are usually the steps, if we break it down, about how we are monitoring our blades and how we are conducting this kind of inspections. So the technician offshore is the eye of the assets, and engineering transforms those observations gathered not only by the drone campaign but also by the technicians in order to provide the right decisions.
And if we talk about, so obviously, I think the majority of it is done by the drones, but in those more complex cases, technicians are actually involved with rope access. So can you tell the average, let's say, percentage, let's say 80% of the work is done by drones and 20% by technicians, or it is not calculated like that?
It's hard to evaluate because it's true that the first inspection is conducted by drone because it's way leaner. You can fly a drone and you can have full investigation of around about 45 minutes, all three blades inspecting by locking the rotor once in bunny positions. It's a very lean process, while by rope access, when we are talking about 73.5-meter blades or 107-meter blades, we are talking about multiple shifts. So therefore, the percentage, I mean, is for sure that we are utilizing 100% sure the outcome of the drone just because it's leaner. Also with the digital tools, the post processes are much faster. So the impact at this first stage on the blade categorization of defects on the drone campaign is 100% clear that the drone is the way to go. Then, when it's not enough, so meaning like maybe run about 12% of the defects or up to 20% of the defects that they are unknowns, we need to send rope access technicians to do more or a deeper exploratory investigation. And out of those 20% extra rope access investigation, then end up, I don't know, round about, depending on the site, by between 10, 12% people or cases of those findings that need to bring a remedy plan, and maybe we need to utilize a platform in some of those cases. So this would be more or less the percentage. So for me, it's clear that there is no better replacement that drone campaign for this first categorization of the defects.
Who are the people who actually do the inspection by drones? Are they the same technicians, or is it like completely separate specialists who are only trained in flying drones, and their job is just to fly drone and show whatever needs to be inspected? Or is it now a part of technician's job as well?
By my experience in GE Vernova, we are utilizing third parties, meaning that we are consulting directly experts. So those are companies that they have been evolving and developing the technology of drone capabilities. So drones have been larger over the years, better capabilities. For example, once we had an event that one drone hit a blade and sink into the sea. So that was not a favorable situation. And nowadays, all the drones that we are hiring, they have floating systems. So all this technology has been developed as well. We are teaching the AI. When I started the campaigns, there were so many mistakes. Like the drone could detect like a bag or some grease spots or stains on the blade, like a blade defect, which was not it. Or on the drilling edge, there were some cracks or that were just dirtiness, but the drone assessed that like a potential catastrophic failure. So nowadays we have been working and cooperating all together. So that's why the outcomes are way more reliable. Therefore, we fully trust on those third parties because we are not experts in all the domains. So we
Yeah.
prefer to get the right manpower, the right competent teams and technology behind this process because every single operation offshore is very expensive. So the most expensive part is to stop the turbine just to perform a drone campaign. Therefore, we need to get the right technology, the high quality drones available on the fleet to execute this campaign successfully and to get reliable data.
Speaking of the AI, obviously 2026, where everybody's speaking about AI, and you touched a little bit on that. So do I understand correctly that AI in your case is it's used for analyzing this vast majority of images and detecting faults automatically? Do they work? Does it work on the, let's say, image enhancing? So in which particular areas AI is helping you with those blade inspections?
So it's the first filter. So when we are relying on AI, is because we have autonomous drone being that is flying around the three blades in bunny position. So we stop turbine only once, and we take all the mapping of the blade effects with this single flight by the drone because they have the autonomy to fly once and to do all the mapping of the three blades. And then this AI is doing the first assessment. That's why I was explaining you that it's very important how this system has been taught, how many learnings they have from the last inspection. So we are building these competencies and this AI based on previous years and thousands of wind farms and blades that we are repeating annually these kind of inspections. So AI is helping here to avoid a massive workload. Like we cannot assess 20,000 pictures per wind farm to
Yeah.
get this analysis done. And it's also a matter of the proactivity. We are running those campaigns early spring. So, we are linked it here into the weather window in offshore. Therefore, we are doing this campaign usually around April, and then we want to utilize 1 month or 1 month and a half maximum to get the deep dive analysis of all those findings, meaning that by the beginning of the campaign, like mid-June, all the outcomes needs to be fully analyzed, prepare the material, the manpower, the access means, and the right strategy to execute all those repairs in between the month of July, August, early September, not anything later here in Europe when we are talking, for example, in the North Sea, because otherwise it's going to be too late and we cannot get any more repairs done. While in onshore fleets, sometimes they can postpone this kind of repairs in 6 months period time. But if we postpone here 6 months, we are starting a autumn winter season and nobody can perform any kind of blade repair at that time. So the added value of this AI is also to get this analysis done quicker in order to let also the site managers decide how to plan their campaign according to those findings.
The obvious question that comes to my mind here, despite the fact that AI at the very first steps, obviously they're a little bit rusty and they need some training, or it needs some training, whatever, however we can call it. And despite the fact that you need to go through that teaching hoops and loops, can you give I don't know, an average analysis or your impression of how much faster or more efficient all these inspections are happening now with the help of the AI compared to pre-AI era? Maybe, I don't know, in days, in weeks, in efficiency, any benchmark you can share from your experience or just your impression?
I would talk about weeks, even 1, 2 months, because post processing all this data is very long. And also, if we are also even comparing the fact of utilizing a drone versus rope access, it's a matter of the accessibility. I got great KPIs, key performance indicators about drone campaigns that were capable of inspecting up to 10, 13 wind turbines in the same wind farm offshore per day. This is a massive progress. Like drone campaigns are running very, very well, very lean nowadays. So we are talking not only about the post-processing of this data, but how to gather this data. In the past, easily one shift per turbine, one shift, we are talking about 12 hours for the technicians, for a team of 3 technicians, 3 roboxes to conduct investigation of all those 3 blades. So, and sometimes it was not even doable if the full shift didn't have nice weather conditions, so mean less than 12 meters per second wind speed, and no humidity, good visibility, no clouds, no low clouds, no fog. So it's taking us shorter period of time, and in offshore environment is definitely a game changer.
That makes sense. And to wrap up on the actual blades, so can you tell a little bit about what particular life cycle the blade goes through in the offshore, and where do you typically step in your role?
That's a very good question. I'm in services department, meaning that after the commissioning phase, the electrical and mechanical completion is finished. So the project team does the handover to service team. It means that usually the OEM is taking care of this service agreement. We sign long-term service agreement contract with our customers because we have the knowledge of those turbines. So the developer relies on our expertise to maintain those blades, those assets running. Therefore, we are responsible, depending on the wind farm, I don't know, for 5, 10, 18 years lifetime. So we are responsible of providing support and to maintain this asset in a good shape. So it's a huge responsibility because we have also commitments with availability, meaning that if we don't execute properly a blade repair, we can trigger that the turbine will be stopped for longer than planned. Therefore, it will kill our availability and we will have to pay LDs, penalizations, because of the lack of the production of our turbine. That's why it's very important for us to maintain over this period that we have this service agreement contract signed up with the developer, the good status of all the components such as the blades.
And what happens with the blades at the end of the life cycle? So when the, let's say, wind farm turbine is disassembled, that's quite a big spare part that everybody ends up with. What usually happens with those?
The commissioning phase, we were talking about assets that have a lifetime of 25 years. Therefore, still in our business of offshore wind, we are starting with those older wind farms to decommission blades, but we have still some years to develop new strategies because this is not fine-tuned yet. How to recycle, how to treat those blades. So this is still a pending topic. We are not yet there. We are running on wind farms. We are talking about 10 years, 12 years of lifetime here when I'm right now in the North Sea, in Mercury Wind Farm. They were built in 2018, so last 25 years lifetime. There's still some time to go. But indeed, we need to take care. This is a green energy sector, so definitely we need to take care about the recycling process and the environmental impact or reutilizing those components. That's another way to do it. Those polyester plates, how to reutilize that, how to give them a second life. That's the way industry is evolving.
That makes sense. And as you stepped a little bit into the future, right, and into a long-term perspective, wrapping up this final section, what you think is still a very stubbornly manual process in your industry or in your day-to-day that you think shouldn't be a manual one? Is there anything that comes to your mind?
Indeed, something that comes to my mind about how we could do it better and is still very manual is this interpretation that we talk and cataloging of blade damage in the field. Because even though we capture thousands of pictures, The process of classifying that damages consistently at a scale still relies too heavily on quality teams. So the post processing of all those AI findings is not accurate enough to make all the decisions. So meaning that we rely a lot into the experience of the individual inspectors. So meaning that people they need very knowledgeable about those findings. Someone with their own expertise here can bring wrong decisions to the field that can cost a lot of money. And there's still, even if we are moving towards AI driven automation, there's still an operational gap to bridge. We are having also scalability. So at offshore install base, we are still continuously growing exponentially, and the bottleneck is still the capacity for qualified inspections and maintenance. We need to shift from a fix on failure mode to a massive predictive maintenance strategy, meaning that with these digitalization tools, we could implement a linear preventive maintenance campaign that will avoid stopping the turbines because of catastrophic damage, and we will optimize every single minute that our teams are spending at the sea. This is key because in offshore environment, it's not the same stopping a wind turbine during the winter season where we have a strong wind, so much higher productivity, and it's critical to maintain the availability during those months. So we need to allocate and to do a good predictive maintenance campaign during the months of the year where we have low wind. That here in the North Sea, for example, we had high wind last week, but it means that usually during the months of July, August, the wind speed is lower, so it's better to plan accordingly of all the maintenance tasks into this window for maximizing the output of our assets.
Cristina, thank you very much for sharing all that and providing an insight to that interesting side of the offshore wind from the blade perspective. And I personally found out a lot of new interesting things. So thank you very much for that. For everybody who joined, stay tuned for more conversations like that, and we will have more guests in the coming weeks. Thank you everyone, and Cristina, thank you very much for joining us today.
Thank you. Thank you for having me here. It was a pleasure.